Hi, my name is Andrew Niles and I am an applications engineer at Semiconductor. Today I'll be covering the comparison of an eFuse to a PTC, as well as a short demonstration of the eFuse features. An eFuse is an integrated circuit with many features, and a PTC is a special type of resistor which has a positive temperature coefficient. Two important eFuse features are that they provide a fast current limit response time and on-off control with their enable pin. In this demo, I will show the eFuse responding to short circuits and providing PWM dimming for an LED circuit. The eFuse shown here today is the NIS 5021, a new 12 volt, 12 amp eFuse. First, I'll demonstrate what happens when there is a short circuit. Setting the switch to eFuse mode, we will press the output short button. The short circuit being generated is a chattering short generated by a microcontroller. Due to the fast response of the eFuse, the 12 volt input voltage rail does not go down. It's also important to note the level of current. Right now the current is 10 amps per division. For comparison, we will also do the short circuit with a PTC. When a short circuit occurs, they heat up and transition from a low resistance state to a high resistance state. Since the PTC must wait for heating, the response time is significantly slower than the eFuse. There is a larger amount of current, which causes the voltage on the power rail to go down. This type of drop in voltage on the power rail could be problematic in the event of other mission-critical equipment requiring the same power supply. Additionally, it requires a power supply powerful enough not to enter current limiting mode due to the high current. Next, I'll show the PWM dimming capability of the eFuse. This is interesting because there is no need for a separate switch. Conventionally, there would need to be a fuse and a separate transistor, such as a MOSFET or a BJT, to accomplish the same task. Since the PTC is a two-terminal device and lacks an enable pin, it cannot be used for the same purpose without a separate transistor. At a basic level, an eFuse requires at least 3 terminals due to its architecture. These terminals are input, output, and ground. In some cases, it would be better to have a 2-terminal device. Since the PTC does not require a ground pin, current only flows from input to output. This means that no bias current is required at all. This is an obvious advantage for battery-powered applications. However, the latest eFuses from Semiconductor have reduced bias current considerably, which helps to mitigate this concern. Thank you. For more information about the features and advantages of eFuses for your application, please visit us at www.onsemi.com.